All right, welcome back. In this video, we're going to talk about quadratic equations. We're going to look first at complex numbers, kind of as a preliminary tool to make sure you've got a good understanding, a basic understanding of complex numbers. And then we're going to dive into all the methods we can use to solve a quadratic equation and practice those together. Okay, complex numbers, these are numbers of the form a plus bi, where a and b are real numbers. The I there is called the imaginary unit. We use I to represent the square root of -1. If we do a lot of work with I, it may be important to know that the I squared, if we squared both sides, the square root goes away, and so I squared is -1. In this section, we're going to see this most when we use the quadratic formula or we solve by the square root method. So we might need to simplify the square root of a negative number. For example, the square root of -4, right? I'll break this out for you so you can see the reasoning behind the result that we get. You could break up -4 into -1 times 4. The square root of -1 is where we get the I. And the square root of 4, we know that's 2. So this becomes 2I. Okay, and anytime we have a negative under the square root, we're going to rewrite it with I. Let's say we had another one like the square root of -18. We could do the same thing. Now, 18 is not a perfect square, so it's not going to come out perfectly even. You will need to know how to pull things out of the square root. So we would like to break up -18 into two numbers that, where one of them, two numbers that are multiplied together to be 18. One of them, hopefully, could be a perfect square. 9 times 2 is going to work out the best. Okay, so that means we're allowed to break up the square root. The square root of 9, we know that's 3. The square root of -1, that's our I. And then we can't take the square root of 2 evenly, so we leave that under the square root. There are lots of ways to do this process where we take the square root of a non-perfect square and bring things outside. So whatever you've learned is definitely okay to use in our class. A complex number can have what's called a conjugate. So complex conjugates differ only by the sign in the middle. And so the two complex numbers that are conjugates are going to come up in this chapter and a couple other chapters in this first test. So what makes complex conjugates unique is that we could multiply them and we get a real number. So let me give you an example of that. If we had, I'm just going to make something up, 3 plus 2i, and we multiplied by 3 minus 2i, we could use FOIL to multiply these. So we'd have 9 minus 6i plus 6i minus 4i squared. So the minus 6i and the plus 6i, those are going to add to 0. Remember we said way up here that I squared is -1. So this becomes 9 minus 4 times -1. Really that I squared is just going to change the sign. And so when we multiply conjugates together, all the i's drop out and we are left with a real number. So this is going to carry some consequences later on. Sometimes we can do some factoring and take a polynomial with real number coefficients, factor it to have zeros that are complex numbers. Okay, so complex numbers very often show up in pairs, and those pairs are conjugates. All right, so now let's dive into solving quadratic equations. quadratic equation, the standard form looks like ax squared plus bx plus c. The solutions of this equation that are real numbers show up as the x-intercepts of the graph. So if I have a parabola, the solutions that I get will be the places where that parabola touches the x-axis. It may be in 2 places, it may be in 1 place, it may be in 0 places, right? If we get complex number solutions, that's going to tell us that the parabola does not touch the x-axis. Okay, so all those things are tied together. You're probably familiar with ways that you can use to solve a quadratic equation. We take quite a bit of time in college algebra to talk about this, so I'm not going to do copious amounts of examples, but I will do a reminder example for each, and then we'll talk again about completing the square for solving an equation. So we can do factoring. If you need some factoring review, I have a college algebra video that you can use to brush up on that. We can use the square root method. We can use the quadratic formula, which I've listed down here for you. The quadratic formula, I hope that you already have memorized. I make all of my college algebra students memorize that. And I think that's pretty essential if you're going into the STEM field. Okay, and then we'll talk about completing the square. Before we get to solving problems, let's talk just for a second about the quadratic formula. There is part of the formula that's called the discriminant. This is the part that's underneath the square root. This is b squared minus 4ac. And so the value for just that part can predict what type of solutions we're going to get from our quadratic equation. So if the discriminant is positive, we're going to get 2 real number solutions. If the b squared minus ac is a perfect square, then that real number solution is going to become a rational number, so it'll be a fraction or a whole number, which is very nice. So 2 real solutions is kind of like the picture we drew up there, where the parabola touches the x-axis in 2 places. Okay, if the discriminant is 0, that means this whole square root part is 0. So the plus or minus doesn't really have an effect in that case. It's plus or minus 0, which doesn't change anything. So we end up with just 1 real number solution. And in that case, the parabola is just touching the x-axis at 1 point. Okay, usually when that happens, there's a double root, one that has a multiplicity of 2 because it's bouncing back. That's going to show up in the next video. Okay, and then the last possibility is that the discriminant could be negative, and in that case, we're going to get 2 complex number solutions. When the solutions are complex, the parabola does not touch the x-axis. And those 2 complex solutions are going to be conjugates of one another. They show up together in pairs like that. All right, so let's look at some examples of quadratic equations. Start with factoring. I just took some problems out of your book to use as practice here. This is number 57. We want to solve by factoring. So we're going to factor this. I'm just going to use the trial and error method. If you'd rather use the AC method, that would work here also. The trial and error method is like taking FOIL and going backwards. So I want to put 2 things in the front here that multiply to be negative 3x squared like negative 3x and x. I want to choose two numbers in the back here that multiply to be 4. You could choose 4 and 1, or you could choose 2 and 2. I usually like to start by trying the two numbers that are closer together. So I'm going to start with 2 and 2. And then I want to try to organize the signs so that the outside and the inside add up to this middle term. So on the outside, I'm going to have negative 6x, okay? Inside I have 2x. If I can subtract those, I can make it add up to 4x. But I would need the 6x to be positive. So I'm going to make this a negative 2. And I'm going to make this a negative 2. And I think that's going to work, because then we'll have positive 6x and negative 2. And it's always good to double check the last times the last. Negative 2 times negative 2 makes a 4. The next step is to use that zero factor property, which says if I multiply two things and I get 0 as the result, then one of those two things, maybe both, were 0 in the first place. So I set each part equal to 0. I solve for x. Okay, and so I get two solutions. Now I kept this negative down in the denominator. You can put it either in the denominator, you can move it to the numerator, or you can write it out front. Any of those are equivalent. That's the factoring method. Let's look at the square root method. The square root method is good if all of the variables are sort of bound up in the squared term. If I had an x to the first term hanging out here, I wouldn't be able to use this method. Okay, so the steps that we take, the first step is to isolate the squared term. In this problem, this is number 50 from your book, that's already been done for us, so we don't have to do that. Then we would take the square root of both sides. Anytime you take the square root is not already part of the problem, you want to include a plus or minus so that you get both possible answers. The square and the square root are opposite operations. Those are going to cancel each other out. And then we want to get x by itself. So I get two answers here. I get 7 minus 2, and I get negative 7 minus 2. So that's going to give me 5 and negative 9. Okay, so this is the square root method. Usually the square root method is not applied when we have the standard form, right? This is more like the vertex form is not the word for it, but usually it's organized more like that. It's already been factored. Sometimes it just has an x squared, but if we have a parentheses squared, that's when the square root method is going to be the most useful. All right, let's try the quadratic formula. This is number 59 from your book. This one's a kind of a crazy one because it's not organized the way we were used to, so we need to do that work up front, which is not too bad. We can do that. So we would want to FOIL these together. I'd have a minus 6x and a positive 5x, so that's going to minus 1x, minus 30. And we want to do the same thing on the right-hand side. So we have a 2x squared. On the outside, a negative 8x. On the inside, a negative 1x. So negative 9x plus 4. And then we would like to get everything together on one side. Since the 2x squared is on the right, I'm just going to move everything over to the right so that the front term stays positive. So over here I'm going to have a 0. 2x squared minus x squared would be x squared. negative 9x plus 1x would be negative 8x. And 4 plus 30 would be 34. And then I'm going to use the quadratic formula to solve from here. So I have the opposite of b. b here is negative 8. So the opposite would be positive 8. Plus or minus the square root. I always recommend that you put the b in parentheses so that you don't forget that when you square it, it becomes positive. I would say, just because I've graded a lot of papers, that's the #1 mistake. Minus 4 times a, which is 1, times c, which is 34, all over 2 times a. Okay, and then we could work out what we have under the square root. So this will be 64 minus 128. Is that right? No. Sorry, I shouldn't do that in my head. 128, no, it would be 120 plus 16, so 136 over 2. Oops. So that'll be 8 plus or minus the square root of, I think this comes out to negative 72 over 2. Okay, so for the square root of negative 72, what can come to the outside? Definitely an I, because we have the negative. You could do this a lot of ways. 72 is 36 times 2. So when I take the square root of that 36, a 6 comes out. So this becomes 8 plus or minus 6i square root of 2. All right, now I identified the 36 right away. If you did 9 and 8, and then you broke up the 8 into 4 and 2, you're still going to get to 6i. It's just going to be a longer route, and that's okay. You could do that as well. Okay, and then this 2 in the bottom, remember, divides into both parts. It cannot divide anything under the square root, but it can divide anything outside of the square root. So this becomes 4 plus or minus 3i square root of 2. And this, like this, is totally fine. I'm sure you know that this plus or minus indicates that there's actually 2 solutions here. So in my math lab, they usually ask you to write them separately. Okay, so that's the quadratic formula. The last method that we'll look at is the completing the square. This should look very similar to what we talked about in the last video. So the idea behind completing the square is that we want to take the equation in standard form and factor it. We want to create a perfect square on one side of the equation and then finish up by solving with the square root method. Okay, so I'll run through these steps again. They're very similar to what we've discussed already. We're going to divide both sides by a. We're going to move the constant term, that's the c here, over to the right-hand side. Then we're going to add a number to both sides to help us factor it into a perfect square. Once we've done the factoring, then we'll be all set up to use the square root method. So the completing the square is sort of like the setup for the square root method. Okay, so this is also from your book, number 39. We have 2x squared plus 2x equals negative 1. So actually the constant term is already on the right-hand side, and that's okay. And now we're going to take and divide both sides by 2. So we'll have x squared plus x equals negative 1/2. All right, so we're ready then to add a number to both sides. Like I've said before, I like to draw the little blanks so I don't forget to add it to both sides. You have the same two options when you try to determine what number to add to both sides. You want to choose a number so that when you factor the left-hand side, you can factor it into two equal parentheses. So you can use that logic to determine that number. So I'm going to do that first again here, or you can use that shortcut we talked about in the last video. So if I were to factor this, I would need two numbers in the back, two equal numbers, because I want these parentheses to match, that add up to 1. Two equal numbers that add up to 1 would be 1/2. And I definitely recommend using fractions for the completing the square process. It's usually easier to see the patterns if you do that versus using a decimal. You could probably get by with decimals, but I think it'd be easier to see with the fraction. Okay, and both parentheses are going to add up to +1, so they must both be positive. And if we use FOIL, everything matches up. X squared, 1/2 x plus 1/2 x would be 1x. And then the last times the last, 1/2 times 1/2 would be 1/4. We're going to add here. Okay, so that's the way you can use the factoring to reason it out. If you would like to use the shortcut, again, my shortcut uses this number here in front of x. So I do b over 2 squared, which in this case, b was a 1. So 1 over 2 squared is going to give us 1/4. Notice before you do the squaring, that's what you should get in your factoring here. Okay, if we add this together, we need them both to be fourths. So we could rewrite this, multiply top and bottom by 2, rewrite this as -2/4. If this fraction work bothers you too much, your calculator can do it. I hope that you're fairly comfortable with working with fractions at this point, but I know sometimes that's a sticky subject. So this is going to be -1/4. All right, that's the completing the square part. We've completed the square. It's in that factored format. The rest is the square root method. So at this point, we're going to apply a square root to both sides. Anytime we put in the square root, we have to put in that plus or minus. And so the square and the square root are going to cancel each other out. Square root of -1/4 would be 1/2 I. And then we want to get x by itself by subtracting the 1/2 over to the right-hand side. So again, we get two solutions, 1/2 plus 1/2 I and 1/2 minus 1/2 I. Okay, so this is the method called completing the square. I thought maybe we could do one more of these just to make sure that you've got it. I wanted to choose one that was a little bit more challenging with a few more fractions because those could come up. So this is number 63 in your book. Same steps that we're going to follow. Okay, so the first step, we want to get x squared kind of alone in the front there. So we're going to divide both sides by 2. That's going to give us x squared plus 3x minus 3 halves equals 0. And then we want to move the constant term over to the right-hand side. This time I'm going to remember to leave a space, because the next step is to add a number to both sides. Okay, and the same thing's true here. We can either use the factoring or the shortcut, whichever you prefer. So if I look ahead to the factoring, I need 2 equal numbers that add up to 3. All right. If you're thinking in decimals, 1.5 and 1.5, okay, as a fraction, that would be 3 over 2, and 3 over 2 would add up to 3. The 3 here is positive, so both of these are going to be positive. And then 3 halves times 3 halves would be 9/4, and that's the number I want to add to both sides. If you'd rather use the shortcut, b over 2 is the same thing as 1/2 times b. Which might be easier to look at this time, since, oh well, no, actually, we don't need that because it's a whole number still. Sometimes if this number is a fraction, it's easier to look at it this way. Okay, so you can disregard that for this problem, but you could use that, it's fine. All right, sorry about that. So 3 over 2 squared would be 9/4. Okay, if I want to add these together, I need them both to be fourths. So I would need to multiply top and bottom by 2 here. And then I'd really like to write this as a square. Okay, so we have successfully completed the square. So this is an example where we did encounter some fractions, and that's okay. Right? We worked with it, we added it to both sides. If you need your calculator, pull your calculator in as a help for you. All right, and then now we want to do the square root method to finish solving. So we want to take the square root of both sides. I'm going to be lazy and just throw it on right here. Don't forget the plus or minus is there. Okay, plus or minus. Now I can break this up as the square root of 15 over the square root of 4, which is 2. I'm allowed to do that. In this case, that might help me out because I'm about to move this number over, and that way they would both have the same denominator. Okay, and this is a totally fine answer. I'm pretty easygoing. I'm not picky at all. This looks great. If you wanted to write it as one fraction, which is, I think, the answer that the book would give you in the back, you could combine these together to look like this. All right, so either of these would be fine as solutions. Okay, well, I hope that gave you a pretty good idea of solving quadratic equations. Now you want to go find some examples that you can use to practice this idea and to try out all these methods, figure out what your preferences are, because we've sort of revealed a lot of options for you. Best of luck.